Welcome to qnawire.
So let's first draw a diagram showing all the charges that we have. So let's say this is our x-axis and this is our y-axis, and we have a charge here that has a magnitude q, and another charge over here which has a magnitude 4 times this charge, and the distance between these two charges is d, and everything is in terms of uh, variables, so we don't have any numeric values, and we need to find the position of another charge small q, and the position is x, such that the three charges capital Q, small q, and 4 times capital Q. So these three charges will be at equilibrium. So let's say the third charge is at a distance x from capital Q, and we want to calculate this x first, determine the place of the charge q where the two electric fields have the same magnitude, the electric fields due to capital Q and 4 times capital Q. So this is x. Now another thing, since all these three will be in equilibrium, therefore we can say that the electric field at this point where the charge small q is placed, the net electric field at that point will be equal to 0. Now this means that EQ on Q, that is electric field by capital Q or on small q, plus electric field by the charge capital 4Q on small q will be equal to 0. Basically, net electric field at this point x due to these two charges will be equal to 0. Hence, by superposition, this will be the net electric field will be vector sum of those two electric fields. Now, let's write down these two electric fields along with all the signs. So, this is k times capital Q over x square, and uh, make sure you include the direction. So over here, since capital Q is positive, the electric field will be away from capital Q, hence towards the positive x-axis. So there should be positive sign, which there is already. Now over here, this will be k times 4q over d minus x whole square, and this charge, again, since 4q is positive, therefore the charge over here will be, sorry, the electric field due to this charge will be away from that charge, hence that will point towards the negative x-axis, hence there should be a negative sign before that, and that is equal to 0, because the net electric field at that point will be 0, because we want all three charges to be in equilibrium. Now solving this equation, we'll find x to be equal to d over 3. This is a really easy calculation, so I'm not doing all the uh, small calculations over here to save some time. So now we know the position of where the charge q should be placed. Now we want to determine the magnitude and the sign of this charge small q. Now charges 4 times capital Q and this small q exert a force on the charge capital Q. And since all three charges are in equilibrium, the force or the electric field at any of these 3 points or at anywhere in the vicinity of these three charges will be equal to 0. For example, the first one, we calculated the electric field at this point to be equal to 0 and solved for x. And now we will see that the electric field sorry, the electric field at, let's say, the origin will be equal to 0, and that way hopefully we will find the value of q now that we already know x. So this was step 1. So in step 2, electric field at capital Q will be 0, or electric force. You can also say that the electric force is also 0. They basically mean the same thing. So F net at capital Q is equal to 0, or let me just solve for electric field. So this means that electric field due to 4Q plus electric field due to small q at capital Q will be equal to 0. So let's substitute the equation. So E4Q, so that will be equal to K times 4Q over square of that distance from the point we are considering. So that is D square plus KQ over X square. And that should be equal to 0. But we forgot about the signs. So let's consider that as well. So at Q, since 4Q is positive, so the electric field is away from 4Q, so it points in the negative x-axis. So negative here, and we don't know yet the sign of small q, but let's assume it to be positive as for now. So this means that again the electric field at this point due to small q will be in the negative x-axis, hence a negative here as well. Don't worry, we will deal with this later. So solving that equation, we get q to be equal to negative 4q times x square over t square. Now is the time where we will use this value of x and substitute that over here. So that will give us, oops, I wrote k instead of q. So this is actually small q. So yeah, now we will substitute the value of x, the expression of x, and that will give us d over 3 whole square, and this gives q to be equal to negative 4 times q over 9. So now we see that q is already negative, and uh, so the sign of this charge is negative, and that is contradictory to our assumption. But uh, yes, we consider that to be positive in order to help us with the equation, so that we can take a sign even if you had assumed it to be negative. That way, the electric field would have pointed in the positive x direction, and you would have got a plus sign over here, and gradually you would have seen that the value of q would have come out to be positive, because that is just the magnitude that we are finding, that you would have found. So yeah, so this is the magnitude of this part. The positive part is the magnitude of the charge, and its sign is negative. So on the summary, we can say that the charge q is placed at a distance d over 3 from capital Q, and at that point the electric field is 0, and the magnitude of this charge small q will be, has to be 4 times capital Q over d, and its sign should be negative.